Well, hello and welcome back. It's time for my biannual cold, so I figured I'd do a mailbag video. These things are relatively low effort, so let's get started. So I'm starting this one off with 3 packages, and why 3? Well, they arrived in the mail at the same time, and I'm not sure if you're in focus enough to see this, but it says cable times 1 on all of them. So let's open them up and see what they're all about. So since they're cables, I got to make sure I stay away from the cutty bits. There's a cable. This one feels like it's more distributed. Oh, this is a different cable actually. And that looks like this cable. Alright, let's take a closer look at all these cables. So let's start with this one. All these cables are actually a result of late night cheap bidding. This here is a USB 3A to USB 3B, like this, with a 90-degree angle head. This one cost me 34 cents Canadian at auction. And I do need one of these cables for one of my hard drives that I bought without a cable, so that's handy. These, however, these cost me each 22 and 33 cents. And these are interesting. These are also 90-degree cables. Sorry about the sniffling. Like I said, I do have a cold. But they don't have another end, so they do have the USB 2.0 Type A on one side and a bare end on the other side. So interesting to make your own charge cables or to make cables that tie into devices that will be powered by USB. So any 5-volt device like Arduino or whatever. So I got these for the price, but hey, for powering Arduino, this sounds ideal. Okay, so next on the list is this one here. Looks like 2 cylindrical objects inside. Description is handmade items. Somehow I doubt this. Okay, let's have a closer look at what these things are. What these are, at least what they should be, are automatic center punches. Don't know if you can tell, but that should be a very pointy tip, which it is, and this should retract like this. And the whole point of this is there's a spring-loaded mechanism inside of here, and if you push this far enough, the spring should let go, and this little end here should make a divot into metal in order to then have a drill follow that divot to stay on center. It's an auto center punch. So it's like having a punch with a hammer, like you would just hit the backside here, make a divot to guide a drill bit, but it does it automatically. I have this piece of metal here. It says drop forged, but it also says China. I don't think this is drop forged, but let's see if we can put a divot into this. So if I wanted to drill this, I don't know if you can tell, but the surface is a bit rounded. It'd be very hard to keep it centered. So I'm going to put this punch on here. I'm going to push down, and it should snap and make a divot. So let's see if it works. Maybe I'll do it with my left hand so that you can see. Here it goes. Oh, it's sliding. Maybe I'll have to do it with my right hand. No guarantees, by the way, if this works or not. Oh my god, the spring tension on this is insane. Just listen for the snapping sound. Oh, it did work. Don't know if you heard the snapping sound. There is a divot here. Let me just focus you up here. Right there. You see that divot? Not sure how hard this material is. Shouldn't be that hard. Actually, I can't even feel that divot. Let's try it again. Give it a shot here. There we go. That left a divot. Not a very good one. I can't even feel it. Here, let's see if I can show you. Yeah, right there. See that? That's a divot, but can't even feel it. I'm not sure if it's just this punch that's very weak. There's the tip of it. I almost feel like this punch is made of aluminum. I hope not. Okay. Some sort of steel, but it doesn't feel heavy, so don't think it's particularly good. Well, anyways, these things were only about they were $2.25 each, and I figured I would give them a try. Got 2 of them. But yeah, if I feel this one here compared to the brand new one, I think this one's already dulling, so not hardened, which is unfortunate because you'd think with so much spring pressure they'd actually be good. Oh well, for $2.25, what do you expect, right? Let's move on to the next one. So next one here, very small, very thin package. I do feel something here, and it says bulb transistor. So let's see what this is all about. Oh, LEDs? Let's take a closer look at this. Not only did I have to zoom in for this, but I also had to bring the workbench up, so this is why it looks very weird to you. But what these are tiny, and I'm saying like tiny, SMD transistors. Oh, can't see there. There we go. They're marked with 1 AM on the top, and these are equivalent to 2N3904 NPN transistors, and they are absolutely tiny. I want to start working with really small circuits. I've got this, I don't know, I guess this thought that I can make really small circuits and it'd be really fun. So here we go. I bought 100 of these bad boys, and these only cost me $1.20 Canadian. So if they all work, that's a pretty good deal. Look forward to videos on these pretty soon because I really want to start playing with these guys. So yeah, there we go. I think they're a bit too small to test. How will I test these things? That's a good question. I think I have an idea. This could be an absolute waste of time, but I'd figure I'd give it a shot anyways. This is our tiny little transistor here, and I've got some solid core wire, and I'm going to try to solder this solid core wire onto this guy, onto the pins, and if I succeed, then I will put it in the component tester. I don't know if that was a good idea to put it in the tack. Oh well, figure it out soon enough. Alright, gotta make sure you're in focus here. This solder is way too big. Just by the way, I'm just acknowledging it because I know you guys will too. Okay, solder onto these 3 solid core wires. Oh, it's not going well if the solder won't. This is hilarious. This is not intelligent, by the way. This is not how you're supposed to do this. I just am because reasons. Okay, let's see. Whoops, kind of melting the tack stuff here. Okay, let's give it a shot. Whoa, that's hot. It's one. I don't actually know if that stuck to it. It did not. This was a bad idea. Okay. This was not a good idea. I think I've got all the tack off here. Okay. Let's reset one more time. Okay, attempt number 2. This time I have my wires secured. So I should be able to at least get some solder to stick onto my wire. Well, that's a good sign. Okay, I'm just going to make sure. Yeah, this is just the flux residue. I think so, at least. Hope you guys realize that you should not do this. This is not a good idea. This is just me trying to problem solve in the only way I know how. Trial and error. Alright. Let's get that. It's okay. Upside down might be better. Okay. Come on. I don't know if there's a magnetic attraction going on here. Did that hook it up? We have one connection done. I don't know if you can see that, but that is connected. That is one connection. I need 2 more. It should get easier to hold now, though, considering now there's a little leg tied up here. Just gonna get another piece of little tack. I'm not advocating for doing this, so you can just cool it in the comment section, guys. I know. I know. It's okay. Everything will be okay. Maybe you won't even see this, who knows. Alright. I don't know if that worked. Oh, it did. It totally worked. Okay. We're so close, yet we're so far here. One more wire to go. I'm afraid if I pull this off... Okay, it's holding. Okay, one more wire, guys. That's just laughing at the absurdity of this situation. Okay, gotta rotate this into a specific angle to get underneath here. No, under. There we go. It's okay, guys, this isn't supposed to work. Don't worry about it. Although that may have just worked. That is bonded. Okay. This is bonded. I'm going to carefully bend the pins and get my component tester, so let's give that a shot. I'll bring you back then. Okay, ladies and gentlemen, it all boils down to this. Let me zoom that in for you. So there's our crappy soldering job, but they are electrically connected, and I need to get them into this ZIF socket. Whoa, I put the pins really far apart. So if I get these two close enough, and this one to go into literally any of these. Oh, I need to bump one pin over closer. I'm gonna grab this. Whew. I think that's in. Alright, so let's see. The connection that I would think is the gate is in 3. Then collector emitter, whoops, that popped open. Collector emitter should be in 1 and 2. So let's see what it says, guys. Let's see if I ruin this transistor also. Oh yeah, NPN transistor. The forward voltage of 706 millivolts, so 0.7 volts. HFE, which is the amplification factor of 285. Not only did I manage to solder these huge comparatively wires onto this tiny comparatively surface mount transistor by only ruining one, so I have 98 of these bad boys left. But I didn't ruin the transistor on the way, and I just noticed there is a surface mount pad here. Mind you, I think the pad might be too big. Can try. I've never worked with anything this small. This is like really small. This way. So now what I would call the base is on 2. I don't know if it'll actually make contact here, but let's try. Oh, I got 2 connections. Let's try that. So delicate. No, I don't think I can get them to work. I'm going to try one more time. It's so small that it fits like in the gaps here. So it's absolutely tiny. Whoops, see, I didn't even pick it up there. But yes, NPN, not only is it an NPN transistor, but it'll actually work for what I intend to do with it. Excellent. So, oh, it fell out. I call that a small but valuable success. Let's move on to the other stuff. Okay, so next one is this package, and it says car LED light. Light emitting diode light. Okay. Nothing too special here. Except for they look like 2 different LEDs. Let's take a closer look. Okay, so these are wedge bulbs, automotive wedge bulbs, but I find it fascinating because they're different. If you look at, they're both white because they both have yellow phosphor on top, but if you look at this one here, see how the white is much lighter than this one? So I'm gonna have to light them up to see what's going on here. I think I can bring in my power supply for this. So I have my power supply here. It's set a little ferocious, so let's set that down. Let's just put it to regular 12.4, slightly discharged battery. And turn that on. Let's see what happens here. Okay, it lights. It has a slight bluish tinge, but I'd say that's just cold white. It does light up. And this one, yeah, same thing. Interesting, just two different manufacturers of the same deal. Okay. These were bought in an auction as well, and I'd have to actually check how much I paid for these, but I know it wasn't very much, so, because I don't really need these bulbs anymore. They actually don't last very long. I wouldn't recommend buying them, but they are incredibly cheap, especially if you get them on auction. So before we move on to this one, I actually checked how much I paid for these two LED bulbs, and you know those auctions where you see someone bid a penny? Well, I actually won them for a penny. So this set of two, well, they each cost me half a penny Canadian. So yeah, that's why I bid on these. There's no reason. If it was a dime a piece, I probably wouldn't have bid on them because I really don't need them. So this one now. This one I don't actually know what it is because it says elec quantity 1. Don't know what elec means as far as what I purchased. Oh, well, that is pretty cool. Let's take a closer look. So this is incredible luck that this would show up on the same mailbag. I genuinely did not know what elec meant, but these are SOT23, same size as our transistors from earlier, these guys. SOT23 MOSFETs this time. So instead of a transistor, it's a field effect transistor, so MOSFET. Transistors run current through the base emitter junction, I believe it's base emitter, and the MOSFETs only need a positive charge, at least the N channels, positive charge on the gate. So they do not flow current. So that means that I'm going to have to pull these out of their packaging. These are two different ones. The A09T are 5.7 amps maximum between drain source, and these A6S HB 3.5 amps drain source current maximum. These were $3.50. These were $4 for 100 of them. Let me take them out of the packages and solder them to little pieces of wire and see if we can test these out, just like the other ones. So I think this time I'm going to try something that seems a bit more reasonable. I have some perf board here, and I think I'll be able to line up the pins of this device with at least, I don't know, close to between these holes. So I'm going to see if I can jam it in the end here. I don't know if you can see that, but it looks like if I tin these two side-by-side pads here and here, I'll be able to get the two legs to stick there, and then I can just solder the gate connection, I think it's the gate connection, onto these two pads. Then it can lay wire in here and properly run it. So I'm going to try to do that. At least it'll have a bigger pad area that I'll be able to work with. So let's start by pre-tinning some pads here. Got to be careful with these guys. They like to lift pads. I'm trying not to lift pads. Okay. I won't do the gate connection yet. I want to make sure that I'll be able to do that once it's flat on the pads here. Okay. So now I just got to hold this down. Geez, any little movement. Okay, hold on. I'm gonna stick this down with some sticky tack just off screen, I think. There you go. That gives you guys a nice viewing angle anyway. Okay, flip this the right way around. And I just need to hold this in place right there. Heat up both those pads and we should be in business. Damn. You squeeze too hard, the thing goes flying. If this thing hits the floor, there's no way I'll be able to find it again. Okay. So, no pressure to me. It's just you guys' viewing pleasure here. I think that's on. Just need to solder this connection now. Hopefully that worked. It looks like I nailed it. Okay. So that's one down. This one on this side here, which maybe I should mark with something, that's the A09T, which is the highest output one. So I'm going to flip this around like this and put an A. There we go, an A. Now I'm going to go for the other side here and do the same thing with the other one. And honestly, I didn't think it would go this easily, so let me just set up for that and bring you back. Okay, so same Z's on this side. This is with the A65 or A6SHB. So I'm going to pre-tin these, trying my best not to lift the pads off. I'm going to put a big blob on there too. Okay, spin this around a little bit. This guy, gonna flip it. Okay, it's hard because I'm manipulating this with my left hand, not my dominant hand. Alright, here goes. Whoop. Easy now. I think I got it. Okay, now just going to heat up this pad and pre-tin and bring the solder over. I think I got it. Let me take a look. If the gate is actually in there, it's in there by very little. Try to take this solder off here. And I'm going to try to flow some solder over here. See if I can bridge these two connections. I really want some solder to stay in between these two. That's pretty much the crux of it. There we go. For sure I have it now. Okay, so I'm just going to cut a few conductors and then we will see if we can test these. And this is the this one represents, it's a A6SHB, represents an SI2306. So I'm just going to put an S like that. Okay, so the A and the S. And I'm going to get some conductors and see if I can solder some stuff onto here. Okay, so this time using far more sensible stranded wire. And let's see, these gate connections should be fairly easy to make. Okay, that's good. Going to do the other connection on the other side. I'm actually going to face this one out the other way, which means going ambidextrous on my soldering skills, which they are totally not. Yeah, that was pretty ugly. Maybe I'll just make them go all the same way. Put a touch more solder onto that connection. Got to be careful because MOSFETs are far more fragile than transistors for overheating. At least that's what I've been told. I don't know if that's actually true. Either way, I wouldn't want to kill them with heat. I'm going to have plenty of stupid projects to do with them to kill them. It's going to need a bit more solder. Be careful not to overheat the pad though. All this work will be for nothing if the pad lifts. Okay, doesn't have to be pretty, just has to work. So far no bridge connections, which is nice. Okay. Two more solder joints. This one over here. And last one over here. This makes a lot more sense, you know, soldering to a substrate instead of trying to dead bug. There we go. Instead of trying to dead bug these surface mount components, SOT23s. And by the way, I did think of this. I do have adapters coming in the mail to be able to solder these on and then use them in a breadboard. But until then, this is my solution. Alright, so let's go ahead and plug these into the component tester and see what it reads. And here is the moment of truth. I may have ruined this, but I may have succeeded. Only one way to find out. So I'm going to put, this is our S board. This should be our lower, our 3.5 amp draw board. These are a little hard to put in here, but I'm going to try. Because don't forget, it's a zero insert force, a ZIF socket. So that means that once they're in there, there's nothing keeping it in there until I close the latch. So, oops, now I'm fraying the ends. I still have to be pretty careful because these pads do lift off the board quite easily. So you go in there. You go in there. And lastly, you go in there. No, come on, baby. Don't be like that. The eternal struggle. I should have made these pin headers, but I'll do it now. One. Come on, the circle. Almost. Okay, I got it. Now let's see if it worked. So this should be our 3.5 amp one. No, capacitor. It's not a capacitor. Between 2 and 3. 1 should be the gate. Come on, it's not a capacitor. I could have ruined it. This is possible. I do ruin things. Come on. Come on. Work for me. Ah, darn. It's still showing a capacitor. I know there's capacitance inside of it, but it shouldn't be a capacitor. Okay, you know what? I'm going to pause, solder these to pin headers because they're a bit frustrating right now. And then if it doesn't work, it doesn't work. Let's do that. Okay, I think the struggle is now over. I've got 2 sets of pin headers soldered here. If this doesn't work, well, I don't know. Maybe I damaged it. Maybe this thing's not good at reading MOSFETs. I'm not sure. So let's take a look. Crossing our fingers. Oh yeah, here we go. Gate, drain, source, voltage threshold, 890 millivolts. I specifically picked these MOSFETs because I could turn them on with an Arduino. So that looks perfect. That's the high current one. The only thing this tester doesn't show me is RDS. I want to know the drain source resistance, but that's okay. We can do other tests for that, especially when I get the boards. So this is the lower one. This is the 3.5 amp version. Let's see what we get here. There we go. So voltage threshold 1.09 volts, gate capacitance 495 picofarads, and there you have it. My ghetto testing of Mailbag SOT23 transistors. So it was this guy, this weird spider thing, these guys. Where there's a will, there's a way, right? And that is today's Mailbag. A bit more intense than I wanted to get into, but hey, I wanted to get these things tested. Stay tuned for projects involving some tiny surface mount transistors, but not quite yet. I still need to wait for my board adapters, my SOT23 to dip. If I get impatient though, I might just make my own, sort of like this thing here. But again, thanks for watching.